Welcome to my channel, CodeWithFernando. Today I'm going to start a new playlist. It's going to be called Java Nuggets. This playlist is oriented for people who already feel comfortable with Java. Okay, so today we are going to talk about the string pool. First of all, we need to understand what is the string pool. So the string pool is a JVM Java virtual machine managed cache of unique string literals. This is very important to understand. So, what is it? This is a specialized cache. It stores one shared instance for each unique string literal. Okay, this is part of the JVM memory model, the Java virtual machine's memory model. This is built on immutability, which means a string never changes after creation. We already know that, right? So, sharing one instance across threads is always safe. Then we have the flat width pattern. The flat width pattern, in case you don't know what is the flat width pattern, I have a complete article. The link will be found here on my channel. So this is the same idea as the flat width social pattern. So what is it? Sharing one common state instead of duplicating. This is applied to the Java virtual machine level. So heap since Java 7. Before Java 7, it used to live in the Persian, a separated fixed space. Moving into the heap, let it grow dynamically and be garbage collected. So, the question, what we need to understand here is how the registry lookup works. The compiler identifies every string literal present in our source code during compilation. Second, at class loading time, the JVM checks the string pool registry for each literal it finds. Then we have, if the value of x exists in the pool, the JVM returns the existing shared reference. Then, if it does not exist, the JVM creates a new entry and registers in the pool. 5. Finally, runtime generated strings. This is produced by new or by methods. If in case those things happens, it will bypass this process entirely. So let's continue. What the string pool does? Actually, two effects: memory deduplication and faster reference quality checks. So we have here an example, very interesting example. Without the pool, let's imagine that we have 10,000 concurrent requests, each of them carrying the HTTP header application JSON. And in case that happens, it will allocate 10,000 separate string objects on the heap, each of them independently tracked and eventually reclaimed by the garbage collector, purely to represent the same 16 characters. Okay, then we have the other way. With the pool, exactly only one instance of application JSON exists in the pool. So in that case happens, we all 10,000 requests share one single reference, dramatically less heap pressure, fewer GC cycles, and lower allocation. Cost on every single request that uses a literal already seen by the JVM. So let's continue. String literals automatically pooling. So this is the simplest, most common way to use the pool. Okay, we see our example in here. We write a string literal called Java S1 and S2. Okay, we're gonna see this in code right now. So both variables point to the exact same object in the string pool. JVM, the Java virtual machine, creates just one Java instance and handles the same reference to both. No extra work is required. So okay, let's continue with our example. Let's create a string literal str2 called Java, and the other one will be the other one will be str2. So now let's use double equal operator. str1 str2. Okay, so let's see this with a diagram. Okay, so let's pretend that this is the heap and this is the string constant pool. It's located, right? So we have str1 Java string literal. The JVM checks if there is no one here, it creates a new one. Okay, For str1, this one is created Java. Now we have str2, the same content Java, so it checks the string constant pool check. If there is one already, it will return the same reference. That's why str1 and str2, they both point to the same reference in the string constant pool. If we check now, we are gonna get true. Let's see this. True. Okay, let's continue. New string by passing the pool. An explicit instruction to allocate independently on the heap. So let's try str1 Java, then str3 new string Java. So totally different. This is just string literal, and in here we are creating a new object on the heap. Whenever we use new, we are creating a new object on the heap. So let's see this in action. Okay, let's create a string literal str1 Java. Now str string, let's call this str3 new string, the same content Java str. Okay, now let's see this. Let me copy this. So this is not string 3, and this one will be string 3. So this is going to change, right? So string 1, okay, this is a string literal. It goes automatically to a string constant pool. Let's imagine that we don't have any here. So we just write string str1 Java. It points here to the string constant pool. Now we just write str3, string str3 new string Java. It's the same content Java in Java, but whenever we use the new, whenever we use a new keyword, it creates a new separate object on the heap. It's located in the heap. So that's why if we use the equal operator, right, double equal operator, they both point to the different objects. In here, what do we have? We have false, because str1 points to the one located in the string constant pool, and str3 is pointing to the one located on the heap. So we will get false. What about the content? The content is the same, right? So we'll get true in here. So let's check if this is correct or not. We'll get false, and for the other one we'll get true. Okay, let's continue. Compile time constants. This is automatically pulled. The Java compiler performs constant folding. It resolves constant expression before runtime, which means a compile time. Okay, so let's see this in action. So let's create a string literal. Let's call it s1. This will be rat, and we are concatenating a s. Okay, so let me print this. What are we going to get in here? We're going to get the string literal rats complete. So now let's create a string 2. String s2 will be rats. Of course, we know where we're going to get if we print this. We're going to get rats also. So s1 and s2. Let me print this. Okay, so Java is smart enough. So that Java compiler knows this will be compiled as rats, as single unit. Let's continue with the mental model to carry. 6 technical rules that cover almost every real-world case. Number 1, literals are pulled automatically. Every string literal is registered in the pool at class loading time. 0 code, 0 opt-in required. Number 2, new always bypasses the pool. So this is quite important, and we have seen a lot of exercises. So new string forces a fresh heap allocation, even when an identical literal already exists in the pool. Number 3, constant folding pulls compile time expression. The Java compiler resolves literal plus literal, or maybe final plus final, into a single pull literal. Any non-final operand breaks this. Number 4. Runtime methods never pull by default. So these methods trim, substring to lowercase, StringBuilder to string, okay, all of them, all allocate new heap objects that intern must register manually. Intern is manual per instance and synchronized. It registers one heap string into the shared Java virtual machine wide pool. Number 6. Equals is always a correct tool for content. Double equal depends on allocation history, not on what the object actually contains, so never is a safe substitute for logical equality. That's it. That's this nugget. So if this made the string pool click to you, you know what to do. Like, share, and subscribe. See ya.